Moving on to question 4. The discrete random variable has the probability function as shown below, where k is a positive constant. Show that k equals 0.25. Okay, so we are going to substitute our values of x to get our probabilities into this table. Okay, so when I substitute 0, 1 and 2, I will be substituting into this function here. 0 substituted into there will leave me with 2k. 1 substituted in will leave me with k. 2 substituted in actually leaves me with 0. When I substitute 3, I'm going to be substituting into this second function. And for 3, I'm going to have k. All right, so we also know that all of these probabilities should add up to 1. So I can go ahead and say that 4k equals 1, k equals 1 over 4, which equals 0.25, which is what we were asked to find in the question. All right, before I even move on, since I now know the value of k, I can put numerical values on these. Let's finish off this table. Okay, and those numerical values, I'm going to use fractions. I'm looking for a half, a quarter, 0, and a quarter. Two independent observations of x1 and x2 are made, show that the probability of adding them together and getting a score of 5 equals 0. So probably the best way to show this is with a sample space diagram. So for x1, I can have 0, 1, 2's actually got a probability of 0, so it's impossible to get a 2, 0, 1, and 3. And for my second choice, I can also have 0, 1, and 3. Okay, so let's have a think about what the outcomes are going to be. So here I can get a score of 0. Here I get a score of 1. Here I get a score of 3. This would be a score of 1, a score of 2, and a score of 4. And finally, a score of 3, a score of 4, and a score of 6. And we can see from here it's actually impossible to get a score of 5. None of the combinations lead to a score of 5. Okay, so no combinations lead to a score of 5. Moving on, we'll ask to find the complete probability function of x1 plus x2. And this is why I've actually made so much space in this sample space diagram. I want to know the probabilities of each of these different things happening. Okay, so what is the probability that I get a 0 followed by another 0? It's going to be a half multiplied by a half, which is going to be a quarter. What's the probability of a 1 followed by a 0? It's going to be an eighth. So this is the probability of 1 multiplied by the probability of 0. And finally, the probability of 3 multiplied by the probability of 0 is also going to be 1/8. Okay, if we follow that through and find all of the probabilities for all of these outcomes, so a 0 followed by a 1 followed by a 1, a 3 followed by a 1, a 0 followed by a 3, a 1 followed by a 3, and a 3 followed by a 3. Okay, just a quick sense check. Do these probabilities add up to 1? And are the larger probabilities where I expected them to be? Okay, so we were asked to find the complete probability function for x1 plus x2. So all the possible outcomes and their probabilities. Well, x1 plus x2 what values can x1 plus x2 actually take? Well, it's either going to be 0, or it's going to be 1, or 2, 3, it can be 4, we've already decided it can't be 5, and it can be 6. Okay, these are all the possible outcomes. What are their probabilities? Probability of 0 is 1/4. Probability of 1 is 1/4. Probability of 2 is 1/16. Probability of 3 is 1/4. Probability of 4 is 1/8. And probability of 6, 1/16. All right, and this is the complete probability function for x1 plus x2. Finally, we're asked to find the probability that x1 plus x2 is in between 1.3 and 3.2 inclusive. Straight away, I'm going to rewrite that. It can never equal 1.3. So if I'm saying that I'm looking for scores bigger than 1.3, I'm also saying I'm looking for scores greater than or equal to 2. And if I'm looking for scores less than or equal to 3.2, I'm looking for scores less than or equal to 3. So I've immediately just rewritten this probability statement using the available outcomes. Okay, and probability that I get a score in between 2 and 3 inclusive is going to be 5/16. Okay, laying it out just how I have, using the sample space diagrams, showing the probabilities along with the outcomes will be worth all of your marks.